Hi, I'm Eric, a cloud software engineer at Intel, and I'm going to talk to you about Intel's open source BigDL project. Protecting privacy and confidentiality is critical for large scale data analysis and machine learning. BigDL PPML, or Privacy Preserving Machine Learning, provides a trusted cluster environment for secure big data and AI applications, even on untrusted cloud environments. In this demo, I will show you how to run an end-to-end AI pipeline leveraging Intel Software Guard extensions, or Intel SGX. BigDL makes it easy for data scientists and data engineers to build end-to-end distributed AI applications. It uses the Orca library to scale out a single node instance. It uses the DLlib for distributed deep learning on Apache Spark. In the lower level, BigDL PPML combines various low-level hardware and software security technologies like Intel SGX, Library Operating System or libOS, federated learning, attestation service, key management, and other important items so that users can continue to apply standard big data and AI technologies. Various libraries and frameworks, such as Apache Spark, Apache Flink, TensorFlow, PyTorch, etc., are all used without sacrificing privacy. An end-to-end distributed pipeline using Orca or DLlib allows AI jobs to scale up in a secure manner. This allows trusted big data apps and workloads from data ingestion, data analysis, machine learning, to deep learning to run even on an untrusted cloud. All of these technologies work together to protect the end-to-end AI pipeline, which allows companies to protect their most important data. BigDL PPML extends the single node trusted execution environment to provide a trusted cluster environment so as to run unmodified big data analysis and MLDL programs in a secure fashion on private or public clouds. The computation and memory can be protected by Intel SGX and, in the future, Intel TDX. The network communication is protected using remote attestation and transport layer security. The results are encrypted and securely copied over a network to various distributed storage solutions. All of this can be achieved in your on-premise cluster or can be done in the cloud where Intel SGX is supported. That is, even when the program runs in an untrusted cloud environment, all the data and models are protected using encryption on disk and through the network. And the compute and memory are also protected using Intel SGX enclaves, so as to preserve confidentiality and privacy during data analysis and machine learning. To secure your big data and AI applications in BigDL PPL manner, the environment should be deployed first. Customers should have hardware that supports Intel SGX, a fully configured Kubernetes cluster that could be in your own data center or in a public cloud, Intel SGX device plugins deployed, key management service and attestation service setup, and, of course, the BigDL PPML client container running. First, the user would submit the job to Kubernetes using a Helm chart or using a CLI using the input data already encrypted. Then the BigDL PPML client attests the driver node. The driver creates and attests the worker nodes. The driver and worker request keys from the key management service. The workers read and decrypt the data provided in the beginning and then run the distributed big data ML and DL programs. The output data is then encrypted inside the enclave and written out to distributed storage. In this video, I will show you how to run big data and AI applications with BigDL PPML. We take Simple Query as an example to go through the entire BigDL PPML end-to-end workflow. Machine learning, deep learning, big data analytics applications, such as TPC-H, TPC-DS, etc., can adopt BigDL PPML in the same way. Simple Query is a simple data analytics application to query developers between the ages of 20 and 40 from people of different occupations. I'm going to be using the people.csv file as an input. You need to already have a deployed cluster. I'll use kubectl to show you what Intel SGX resources are running. The Intel SGX plugin runs on each node and is how EPC memory, which means encrypted page cache, can be requested and assigned to pods. For my demo, I am using a control plane and 2 worker nodes. Each node has around 1 terabyte of allocatable Intel SGX memory, the plugin is configured to allow up to 110 individual and unique EPC requests, which can be requested from within a pod YAML. Let's take a look at the dataset that is being operated on. You can see a list of people, their ages, and what their job function is. This type of data should be kept secure. To facilitate the end-to-end BigDL PPML workflow, you want to encrypt the input data in a trusted environment through a key management service. Then upload the encrypted data to distributed storage. First, I want to encrypt the data to be processed. I have a Docker container to make this process easier. A BigDL key management service is used for the encryption. Once the data is encrypted, if you look at the file, you'll see a bunch of random characters. The input encrypted data will be loaded and decrypted in an Intel SGX enclave, followed by data processing, model training, and serving. When the processing is done, the result will be encrypted. All the steps will be executed in the Intel SGX enclave. This protects the data while it's actively used in memory. At the end, the encrypted result will be stored in a Kubernetes distributed storage. BigDL PPML provides out-of-box Python and Scala APIs with encryption data I/O to help customers to develop their own big data and AI applications. There is a code sample to showcase how this is done. When the big data and AI application is developed, you might be asking how to submit a job with PPML. PPML provides two ways to submit jobs. You could use Helm charts or you could use the PPML CLI. If you use a Helm chart to deploy a PPML client container, you can execute the job automatically, or you can manually run a PPML client container and enter the client to submit jobs through the PPML CLI. Let me show you how to do it through the CLI. The BigDL-PPML-submit is a script to submit a job that will create several Kubernetes pods, one PPML driver and multiple PPML workers. The driver node is a central coordinator and it communicates with all of the workers. Worker nodes are responsible for running the task. In this scenario, I have one driver node and two worker nodes. There are a lot of fields that can be configured, including whether to use Intel SGX, how much SGX memory to give the driver, JVM, and executor. In this case, the driver and executor get 64 gigs of memory each. You can specify how many executors to run, the image name, and the number of cores to use. You can also specify what class to use, the input-output path, and of course, details for your key management service to be able to decrypt the people.csv file being provided. Let's run the script to submit the job. While the job runs, it will create a driver pod and two executor pods. If you notice, you'll see that they are in the running state and are currently processing the encrypted people.csv file. If I take a look at its log, you can see that it's using Intel SGX. Now, let's look at the two executor pods that were created as part of the job. I'm going to check the logs of the first one. It is also using Intel SGX. I have a Prometheus dashboard showing the cluster. The dashboard is showing a lot of the BigDL components, including what percentage of EPC memory is used, the number of pods running, and other important information. If you look at the bottom right, you can see that both executors are using 64 gigs of memory, as well as the driver. This matches what was in the script earlier. Now, if I look back at the cluster, those executor pods have completed. The process data was written to distributed storage as an encrypted file. If I take a look at the file, you'll see it's full of mangled data that's not readable. I can use that same Docker container from earlier and the key management service to decrypt the data and show it to you. When the job is finished, customers can download the encrypted result from the Kubernetes distributed storage and decrypt it using the same key management service used earlier to get the final result. As you can see from the data, all of the developers were extracted from the original data model. This is a simple example that shows how big data sets can be processed on a Kubernetes environment using BigDL in a secure, end-to-end, privacy-preserving machine learning workflow. Data is encrypted at rest, securely transferred, processed within encrypted enclaves using Intel SGX, and the output results are stored encrypted. Please check out the BigDL repo. It has code and examples to help get you started on your PPML journey. The project has been around for years and continues to evolve, adding new features and more security. Thank you for watching.